first question would be question 11. Okay. So here you have 5 red balls and 4 blue balls. So I'll just quickly label that here. And you have 2 balls that are drawn from the bag without replacement. And so the result. So you're looking for when they're different colors. So if you were to select, let's say, a red first out of 9, and then you would have 8 more balls remaining, and you're choosing a blue ball. And there's another probability where, so you have the probability of getting a red, then a blue, and then probably getting a blue, probability of getting a blue, and then a red. Well, because you're multiplying everything together, like this whole probability is the same as interchanging these two in a way. So all you can do is straight away just times this by 2. Multiply all that together, and I believe then you get E. Question 13. So you have this function here with which A is greater than 1, and you're choosing a 1-to-1. So which one could be the domain? So just note that it says could be, so it's not necessarily going to be the maximal domain, but it can be just any domain in between. So if you want a 1-to-1 function, well, first what I did was I quickly sketched cos for 1-to-1. For cos to be a 1-to-1, x is equal to 0 here, and x is equal to pi. So we know that inside this bracket, so basically log a of x had to be in between pi and 0. Now if I put both to the power of a, you get 1 is in between x and then a to the pi. Then it was a matter of checking each one of these. So straight away, a, d, and e are wrong, because if you let's say if you sub this into here, if you sub it into this equation, you get negative pi on 2, and that's only in between 0 and pi. So that's why all these are wrong. Here has a 0, and that's exceeding this 1 here. So the answer is C. And that makes sense as well, because you have a pi on 2, which is less than a of pi. If x is a random variable, you have, okay, x is more than 5 is equal to a, x is more than 8 is equal to b. So you're looking at this conditional probability. Well, we know the probability should equal probability of x is less than 5, intersection x is less than 8, all over probability of x is less than 8. And the intersection of these two, we'll like think of it as like a number line. If you have 8 here and 5 here, the intersection is this portion right here. So you basically get the probability of x is less than 5 over probability of x is less than 8. So if x is more than 5 is equal to a, then x less than 5 has to equal 1 minus a. Like think of it, let's say if we have let's say some normal distribution like this, and you have a point a here. I should put 5. If this area is a, then the rest of the area, well, we know total probability is 1. So the remaining area has to be 1 minus a. Similarly, if you have if more than 8 is b, then less than 8 should be 1 minus b. And it's something you have to be careful when you check your options, that you realize, well, this is actually just the same thing as this, just timesing both the top and bottom by -1. So that's why E is actually your answer. Question 15, not question 15, we're doing question 16, okay. So you have a continuous random variable and your probability density, okay. You have a mean and a variance, so, and you're given this. So if you note this one, this is actually the same as the expected value of x squared. And we know variance is equal to the e to the x squared minus e to the x, the whole thing squared. So now it's just a matter of summing this in. So I would say I'll probably let like this whole thing equal a. So we have variance being 5, which is equal to a minus 2 squared, which is 4. So we get a is equal to 9. And that's where you get C. Let's see, question 22, that's the last one. So each of the results of the threads are independent of each other, and so actually I'll probably make this a bit smaller. You have so John hits a bullseye of a single throw, it's a quarter, and Rebecca hits hits bullseye with a chance of a half. So I'll do it this way. So if you have John, bullseye, not getting a bullseye. If he gets a bullseye, it's a quarter. If it doesn't, it's 3/4. If you have Rebecca here, bullseye, not getting a bullseye, you get a half. So John has 4 throws, so I'll say times 4, and here is times 2, just so I know my information. So I'm looking for at least, so the probability of the ratio of Rebecca getting at least 1, and John hitting the bullseye at least 1. So we know at least 1. Like, let's say if your probability of x is more than equal to 1, well, that's actually also the same as 1 minus probability of just getting none at all. And so you can apply that to both situations here. So for John's situation, you're looking at 4 throws. So you have 1 minus, and you're looking at probably when he gets no bullseyes at all over the 4 turns. And so for him to not get a bullseye over the 4 turns will be 3/4 to the power of 4. which is equal to, I believe, 175 over 256. Then you're looking at Rebecca's, which is 1 minus a half, because that's the chance of her not getting it, and that's going to happen twice in a row. So it'll be 1 minus a half squared, which should be 3/4. Yeah. Then it's just a matter of checking the ratio from Rebecca to John. So that'll be 3/4 to 175 over 256. Simplify this, you do get E. Yeah. So question 2 here. So you're looking at, so firstly you got a statue, there's 1 meter tall, and on this date you find, okay, that's fine. Okay, that's fine. So you have a height of H, a diameter, remember, of D, and they found the volume at 216 at this time, okay? And so the cylinder has not changed in 1,000 years, okay? And so exactly, okay, that's fine. Find an expression of H in terms of D. Well, if we're given the volume, then we can easily get a relation. So we know the volume of a cylinder would be pi, its cross-sectional area times by the height in this case. So pi r squared, well, the radius is d on 2, so it'll be d squared on 2 times pi h, which is equal to, so that's not 2, it should be 4, which is equal to 216. So here you can just get a h, which is equal to 864 over d squared pi. 2b, now you have to, there's a short question, finding the surface area. If you want to know a surface area of a cylinder, well, you got this area here and this area here. We know area of a circle is pi r squared, so it's 2 times that. And then if you try and think about, like, if you try to visualize, if you get this portion here and kind of unwrap it out, it becomes like a rectangle essentially. This height is h, but this distance here is just 2 pi r. So your formula is just 2 pi r squared plus 2 pi r h. And I'll quickly simplify that to be 2 pi r times by r plus h. So here we get s is equal to 2 pi r times by r plus h. So now it's just a matter of subbing the radius as d on 2. Something you have to note as well, I forgot to quickly say, you're looking at the surface area of a cylinder, specifically excluding the base. So actually this formula is still is actually wrong in this case, because you're excluding this, let's say excluding this top area, so you're only including this bottom area. So your surface area will be pi r squared plus 2 pi r h. So now you get, so this is just a matter of simplifying. So you sub in your values and then you sub in your h from the previous part. And if you do get the answer, then you can be fully sure. So like that's terrible there. Plus 864 on D. And that's what if you manage to get this exact correct proof, then you can be sure that this also has to be right. Part C, they find the cylinder, so the surface area is a minimum. So we know for minimum, we just have to do a bit of calculus. So I'll find S dash of D, which would be pi on 2D minus 864 on D squared. And so for the minimum surface area, with S dash of D equals 0. And so so I'll just write the first part here. Minus 864d squared equals 0. You solve for d, you do get 12 on pi over third, or 12 times by pi to the negative third. And you sub this straight into your s, and you get 108 times pi to the 1/3. Yeah, that should be fine. Yeah. So find the value of h when s is a minimum. Well, when s is a minimum, we have this value here. So we know d is equal to 12 on pi over third. And we can just sub this into our original relation we have here. We can sub this into h. So we can say that h would equal 6 pi to the negative third meters. I'll quickly add in the meters here just for the unit's sake. Part E, so you're looking for expression of v in terms of h. So on this same day, on this day that there's temperature changes happening. Okay, so he observes, so they return each year. Okay, he observes the volume, it decreases by constant of this much per year. And assuming that the cylindrical shape is retained and d is equal to 2h at the beginning. So again, we know our volume is equal to pi r squared h. And so we can just sub in, well, first we know that in terms of, if we want in terms of h, well, d is equal to 2h, but d, remember, is the diameter. So d on 2, which is the radius, is equal to h. So you sub that in straight away, you get pi h cubed. And that's pretty much why it's also 1 mark as well. Now you have to find dh on dt. Well, if we have volume in terms of the height and we have a rate for volume in terms of time, then we can use related rates. So dv on dh is equal to 3 pi h squared. dv on dt. Now remember, the rate is decreasing by this much. So if it has a decreasing rate, then we have to introduce a negative, which is negative 10. Also, really notice about the units as well. They do. You have to really be careful as well. So we know dh on dt will equal dh on dv times by dv on dt. And that's when we get negative 10 over 3 pi h squared. And that's your answer in terms of h. And I'll quickly put as well, just in case, just put meters per year, just for the units. Find the rate at which the height will be decreasing at the top of when the top of the statue is just exposed. So h measures the height from the ground. So like let's say h was like 3 or something, then it will decrease to like a value of 1. So that's why you can just sub in h is equal to 1, because h is measured from the ground. So all you do, you just write like 8 and h is equal to 1. dh on dt will equal negative 10 over 3 pi. But remember, it's looking at the rate at which it will be decreasing, right? So therefore, you have to look at the magnitude essentially. So if the rate in itself is already decreasing, the rate it will decrease would just be at the positive value. So like I'll say the rate of decrease. So therefore, the rate of decrease is actually 10 on 3 pi. And I'll write in terms of units, meters per year. Yeah, that's pretty much it. Yeah. Part H, find the year. Find the year. Be careful because you're looking for finding the year, not just the time. You're finding the year which the statue would just be exposed. So you have dh on dt, which is equal to negative 10 on 3 pi h squared. So this is where I was definitely confused at one point because I didn't know what other information there was. But we're assuming that the melting starts at this date, and we know at that date. Specifically, they mention here that they find the volume of the cylinder to be 216 meters cubed. And so let's see if they specify. Anyway, yeah, I guess you can say, well, this is kind of part of it too. But yeah, the cylinder is 216 at that date, at the 1st of January 2010. And that's the same thing here, same exact date. So first we let the volume equal 216, which our volume is pi h cubed, we found in the previous part. And so we can get a h straight away, which would just be 6 pi to the negative a third. So our t value, so if I separate these variables here, we get integration of dt of 1. So let's say 0 to like t1, let's say. We're integrating dh, so let's integrate negative 3 pi h squared on 10 of dh. And so initially is the height is 6 pi negative a third. And we're reducing to when the top of the statue will just be exposed, which is just 1 meter. You simply calculate this and you'll get some weird value, but the approximate will be 21.29 years. But remember, the question is asking for what year. And so if you add that year, then if you add this by 2010, then you will get around 31.29. And so basically you're looking at this year. So therefore we can conclude that at 2031, the top of the statue will be exposed. Question 3. Do we need question 1? Question 4. Yeah, question 4. So you have a gardener who sells basil plants and coriander plants. The height in centimeters, normally distributed mean 14 is standard deviation. So I'll quickly say that basil, that's a nice B, has a mean of 14 and a standard deviation of 4. They're both the same unit, so it's totally cool. We have a 2,000, and tallest 10% of the basil plants is super. So I'll quickly write in terms of my working, but to let B equal the basil plant height. So the probability that the height will be more than a certain value, so I'll say h here, would equal 0.1. And so you get a h, let's see, so you get your h, yeah, no, this works. So your h minimum value, I'll probably put min here just because you're looking for minimum height, is equal to 19.13 centimeters. But remember, the question is asking for the nearest millimeter. So you have to round it accordingly, which is equal to 191 millimeters. Now looking for them, so they'll move the basal plants if they're less than 9 centimeters. So how many plants will she move? So first we need to find what's the chance of that happening. So probability for B to be less than 9, and that's equal to, so I'll write the notation down for normal distribution. So 14 is our mean and our variance is 16, given that the probability of B to be less than 9. And that should equal 0.1056. And so if you want the amount of plants that you'll move, so this is the probability for the plants to be less than 9. And so if we have 2,000 here, then we can expect for 2,000 times by the same probability, and we should be expecting, so we get around 211.3 plants. So we're expecting this much plants to be to have a height less than 9 centimeters. I mean, we have to correct the nearest whole number. So therefore I can say that 201 plants will be moved. Next part, we have the heights in centimeters with a density function of the following. So if looking for the mean height, so we know the mean height, or I'll say e to the x here, is the same as integrating from its own boundary of x times by the whole function itself. It is a 1 marker, so this is only the line of work I'm going to put in. I'm just going to say, you put this straight into your CAS and you do get 25 centimeters. Now you're looking for the things like the smallest 15% of the coriander should be given a Newton plant. Okay, find the maximum height correct to the nearest millimeter of the coriander plant if it is to be given a Newton plant food. So the smallest 15%, okay, and if to be given the new type, okay. So for it to be given, we'll have, so I'll quickly say, let's see, equal coriander plant height. So we're looking at the probability for C to be less than a certain height, let's say H max, which is equal to 0.15. So you basically put this into your function, so you would integrate, so I shall write that down, from 0 to, let's say, H max of 12, oh, so that's wrong, of H of x dx would equal 0.15. So your H max is equal to 12.659 centimeters. Question is asking for nearest millimeter, so your H max is equal to 127 millimeters. Which also grows in cells to one part. She classifies either tall or regular. So she finds 20% of tomatoes are tall. Now you have a certain value, certain amount of tomato plants. So like QB, the probability at least one of these plants will be tall. Okay, so I'll quickly write as well, yet again, let T to be equal to tall tomato plants. And so what they're looking for is Q. They're looking for Q to be greater than 0.95. So basically we're looking at probability that T is more than or equal to 1. So we're looking at least 1. So T has to be more than or equal to 1, which is more than 0.95. This is also the same as well, like in the previous MCQ, this is the same as probability of 1 minus for none of them to be tall. And so we can rearrange this. So this expansion here would be, so we're looking at n choosing 0 of, we have the probability of, so what's the chance, 0.2. So you have 0.2 to the 0 times with 0.8 to the n. So this whole thing is equal to 1 and this whole thing is equal to 1 as well. So what we get is 0.8 n. So we rearrange these variables and yet this is less than 0.05. Put this straight into your CAS, you get n is more than 13.425. So therefore we can conclude that n has to, for the n minimum, has to equal 14. You round up because if you have 13, well, that means it's not going to satisfy this inequality here, so you have to round up. And notice, well, N is the number of tomato plants. You can't have like 0.5 plants, so you have to write 14. So we'll say 14 tomato plants. This part, so you have section is nursery, either your pots classified as smooth or rough. You just go to the next page. Okay, so over a period of time was smooth. Okay, so this is just how the table goes. So I'll draw like this. This is normally how I do it. So if you have a smooth one, what was this, rough? Okay. So over a smooth one, you go from smooth. So from a smooth to a smooth or rough, okay? So if the plant is smooth, then the next smooth one would be 0.7. So this is 0.7, this probably is 0.3. And from, so if one is rough, then the next probability to be rough is P. So if this is P, this is 1 minus P. And so if P has to stay fixed for 1 week at a time, okay, so it's fixed for a week at a time, but can vary from week to week. And the first part is always a smooth one. So finding terms of P that the third part is given, is made in a given week is smooth. So we know the first one's always smooth, so this one's fixed. I'll leave it like that. And so for the third part, would be the third one, has to be smooth. So I'll quickly roll that out. So you have smooth. So you have two alternatives. Either the second one is smooth or the second one is rough. So you're already given this. So this doesn't need to be included in the probability. So you're looking at the probability for to get a smooth and then a smooth, or a probability of getting a rough then a smooth. A probability to get smooth and a smooth, well, initially is smooth. To get two smooths will be 0.7 squared plus, and then to get a rough, so smooth to rough is 0.3, and then, actually I'll do a different color, 0.3, and then from rough to smooth would be 1 minus P. So we times by 0.3, 1 minus P. Simplify this and you get 0.79. Well, you keep it in fraction form, doesn't matter too much. That's what you should get. In a particular week, a third part is made to be smooth. Well, we found for third part, this is a probability. So you're looking for the calculate P. Well, we just know that 0.79 minus 0.3 P was equal to 0.61. So P should equal 3 on 5 or 0.6. Here, this is just long-term probability, so don't worry about that. Let's see, question 5, you have two functions here. So you express x to the 4 minus 8x into that following form. So we can factor x out straight away and you get, so I'll say gx. Actually, that's not what I'm really asking. So yeah, x of x cubed minus 8. And so this should seem familiar if you remember this formula here, this expansion of the difference of cubics. And there's this formula that you can use. So x times by x minus 2 times by x squared plus 2x to x plus 4. And here, because you're looking for complete the square here, so you have x minus 2. This would be x plus 1, the whole squared, minus 1 plus 4, which is just plus 3. And that's your expansion there. Describe the translation that graphs this onto this graph. If this is a little confusing, I would recommend just straight away sketching into the CAS. You can kind of see like what's happening here. If you have x plus 1 here, coming from x squared plus 3. So you're looking at fx onto here. So you can see x squared plus 3 becomes x plus 1. And you have x minus 1 becoming x minus 2. So really what's happening is, or if you want, you can sketch the graph as well, and you'll find that you're simply just translating the graph. You're translating the graph 1 unit to the right. Sorry, to the left. I write like this for now, but in my working, I write negative direction of the x-axis. It doesn't matter, same thing. Find the values of d for the graph fx specifically has one positive x-intercept. So if we sketch the graph here, if I remember correctly, yeah, the graph will look like this, where this intercept is 3, this one is 1. Just quickly check that. Yep, that's all right. So looking for one positive. Remember, positive is a keyword. And so if you want one positive, then this intercept can't exist. So this has to be in the negative region so that only one positive exists. So we know that if this moves by 1, well, if it's on 0, we know 0 is not classified as a positive or negative number. So we know that for D, well, in this case, D is actually positive, right? So if you sub in a positive value, then the graph moves to the left. So we know the smallest boundary can be 1. And then it can't, but this 3 can't hit the x-axis. Like this intercept can't hit the x-axis or the y-axis, sorry. Otherwise, it's not classified as another positive intercept. So You're looking at 1 inclusive but 3 exclusive, essentially. Now you're looking for 2 positive intercepts. Well, you're looking to try and shift the graph more to the right rather than to the left. So we know that for the minimum value, this 1 has to be onto here, but we want 2 positive, so 1 can't be included. And if we try to shift the graph to the right, well, we have to sum in negative numbers so that the graph shifts to the right. So therefore, you're looking at negative infinity to 1, exclusive for both. Now, even with the value of n, for which g of x equals n has 1 solution. Well, if you sketch g of x, it should look like this, which this is 2. And you see, like, let's say y equals n will be just a straight line like this. And for only 1 solution, it will only hit this turning point here. This turning point, I don't remember the exact, oh no, we found I think we did find, no, we didn't find the minimum. So this minimum will be at like 2 to a third or something. You just find this x coordinate and find the y, this corresponding y component, maybe just using your CAS, and you'll get that n would equal -6 of 2 to the third. So now you have a point UGU at a gradient of GX is M and a point VGV, the gradient is -M. So they're both like the same gradient, but like different directions. And that kind of makes sense as well, because if you look at the graph, so we're looking at GX, so they'll look like this. The graph, because of the symmetry of the graph here, it's kind of like a parabola. No matter no matter the y point, the gradients will be pretty much negative with each other. Or in other words, they both will be perpendicular only up until the turning point. So it doesn't matter too much, but it's just good to know. So then you're looking for the value of u cubed plus v cubed. Well, g of x is equal to x. Well, let me find this again. X to the 4 minus 8x. So now we're looking for a cubic here. So we know that if we diff this, 4 will come here and the cube will remain. So if I get g dash of x, we get 4x cubed minus 8. Now g dash of u will equal let's see, 4u cubed minus 8, and this gradient is equal to m. So we can make this equal to m. So similarly, we can subject u cubed because we're looking for what u cubed plus v cubed is. So u cubed is m plus 8 over 4. Now, if you get g dash of v, this was equal to 4u cubed minus 8, which is equal to -m instead. So this should be v. So v cubed is equal to 8 minus m over 4. So now you can just sub these values in. U cubed plus v cubed, which is equal to m plus 8 on 4 plus 8 minus m on 4. You see these m on 4s cancel out and you get your answer is 4. So this is equal to 4 ultimately. Then you find u and v if u plus v is equal to 1. So we know u plus v is equal to 1. U cubed plus v cubed is equal to 1. That should be 4. And so now you just simply put this into your CAS looking at using the function. So you go menu on the CAS 3, 7, 1 and get your system of equations. And you do get a bunch of different, I think you get 2 sets of values of x for u and v. But something to notice as well, because of the symmetry thing I kind of put up here, this point will be like 2 to the third, and u has to have a positive gradient, which is this this portion here. And so therefore, u has to be more than 2 over third. I don't remember the exact value, the x coordinate here, so I might be wrong. But the v should be less. Oh, actually, I have it here. It should be. Okay, it is a third, yeah. And therefore, v has to be less than 2 to the third, so that it has a negative gradient. So, all right, here, as u is more than 2 to the third. I think in the VCOS solutions, they used negative and positive as a justification. Pretty much same thing. So you have u is equal to √5 plus 1 on 2, and v is equal to 1 minus √5 on 2. One question on tangent here. So you can use your tangent line function, which is at menu 4(9), I believe. Menu 4(9). That's where you have a tangent line. And it is just a 1 marker. So I think just stating it really is all that's required. So the y tangent is equal to 4 of p cubed minus 2 of x minus 3p to the 4. Now you look at the equation of the tangents where they pass through the point here. So it's just a matter of subbing it in. So, y tangent of 3 on 2 should equal -12. So you get -12 is equal to, so if you sub 3 on 2, there'll be 6p cubed minus 2 minus 3p to the 4. So you can simplify these parts here and you put them all to one side and you get p to the 4 minus 2p cubed, which is equal to 0. So now it's just a matter of solving here using the factor law. You get p equals 0 and p equals 2. And you're looking for the equation of the tangent. So I'll say add p is equal to 2 and add p is equal to 0. Y tangent, okay, I'll just write these both here. You just sub this into your p-values into here. So if you sub in p is equal to 2, you get 24x minus 48. And if you sub p equals 0, that's equal to 8x. And if you want a good way to check how to do, if these answers are correct, well, you can use this function again and instead just let x equals 2 or x equals 0. I did it and I got the exact same. So yeah, those are all the answers. And yeah, that's all. That's it.